Okay, so the last section we're going to look at for this week is 3.7, and it's going to tie in with a little bit of what we did yesterday with transformations, but we don't do as many of them. Okay, we just stick to the simple ones, like moving up and down, moving left and right. So the idea is basically what's going to happen when we transform an absolute value equation. So like if I had something like this, let's say absolute value of x plus 3. I'm going to show you what absolute value looks like, but can anybody tell me what the plus 3 would do to it? Even if you don't know what it looks like. We should know from yesterday what adding a number on the end is going to do. Does anybody remember? Adding a number on the end. Yep, exactly. So whatever this looks like, the plus 3 is just going to move it up 3. Yep. So that's what I'm going to show you how to do. All right, so what is an absolute value function? Okay, so on the blank line, you want to fill in an absolute value function is a function that contains an absolute value expression. And what did we say the symbol looks like for absolute value? Yeah? Well, the graph of absolute value is a V. But what's the symbol that we use to represent absolute value?
2 lines.
Yeah, 2 vertical bars. So something like this. That's an absolute value function because it contains absolute value bars. How about something like this? Does that have absolute value bars in it? Do you think, Marie?
No.
No, that's not an absolute value function because it doesn't have any bars in it. Now, what if I did this? Does it have absolute value bars now?
Yeah.
Yep, then now it's an absolute value function. Okay, so it has to have the bars in it to be an absolute value function. Now the simplest absolute value, this is not the simplest one. That one's more complicated because it's got a 3 in the front and it's got a -4. This is the simplest thing. Y equals the absolute value of x. So on your guided notes where it says the simplest absolute value, this is called the parent function. That's what they call the simplest function in a group of them, parent one. And it's just y equals the absolute value of x. Now, absolute value looks a little bit different. It's not a line. Does anyone remember what shape I said it's going to be when we draw a picture of it?
A V.
It's going to be a V. Yep. And what it looks like is that graph in blue. Okay, that's the shape of it. And you'll notice that like all of a sudden it changes direction. Like it's going down, and then it's like it bounces off of it and it starts going up. Where it kind of bounces off, that point is called a vertex. That's the point where the graph goes down and then changes direction. Okay, any questions on that? Now, we've talked about domain and range before. We're going to talk about them again with this problem as well. Does anybody remember when we say domain? Domain is connected with a certain letter. Which letter is domain connected with? Is it the X or the Y? And remember, yeah, domain is the X. And what about range?
Y.
Yep, range is the Y. Okay, so let's look at this absolute value graph. Domain is the X. Which way does the X-axis go?
Horizontal.
Yep, it's horizontal. And which way does the Y-axis go?
Vertical.
Vertical. So we want to imagine that if we were to zoom out, okay, these two shapes of the V, they would just keep going. So how far left and right do you think that V shape goes if you just keep zooming out?
Infinite.
Forever. It just keeps going. It never stops. Right? So the domain, we say, is all numbers. Every single absolute value problem has a domain of all numbers. You can't find one that doesn't. Okay? All of them are all numbers. Now let's look at the range. Does it look like the V shape goes up forever and down forever?
Yeah. Well, it looks like it stops. Like
Right, it stops. It doesn't keep going in which direction?
down.
It doesn't keep going down. Okay, all of a sudden, it stops. Does it look like it goes up forever?
Yes.
Yeah, it will. It's going to keep going up on an angle forever. So it does go up forever. Doesn't go down forever. How far down does it look like it goes and then it stops at that number? Yeah. So we say the range is all numbers greater than or equal to 0. 0 is the lowest, and it goes up from there. Now, what if you had a V shape that looked like this?
Three.
Yeah, the range in that one would be all numbers greater than or equal to 3, because 3 is the lowest, and then it keeps going up forever. How about if I had something like this? What do you think the range would be there?
Three. Like
So 3 means that it never goes lower than that dotted line.
-3.
So -3 would mean that it goes down this far.
Oh, 0.
0. Yeah. The range on that one is 0. That's the lowest that it goes. And then you have to say that it goes every number greater than or equal to 0. How about if I had like a V shape like this? What's the range there?
0.
0 and
Up.
up. Yeah. So it's every number 0 and up. Yep. The domain is the same on all of them. The domain is all real numbers, all numbers on every problem. But the range can change. It depends if you move the V shape up or if you move the V shape down. What do you think the range would be on this one? Yeah?
-2.
-2 and
Below.
it goes down from -2?
Yeah.
So the graph goes down in this area? I don't see the V shape down in that area. So the range is -2 and
And above.
above, right? It doesn't go below -2. It goes above.
I thought you were talking about just the point where it goes to.
So you got to look for the V shape, and you got to look at which way the V shape
I
goes.
see. I see.
So it starts -2 and above. So you could write -2 and above. We would normally just say this. Greater than or equal to -2. That means -2 and above. All right, I think we're going to skip over that, and we're going to go to graphing absolute value functions. Do you guys have that next on your guided notes? Okay. So we're going to do kind of like we did yesterday. We're going to make a table of values. Except today, I am going to tell you which values to pick. Right? Yesterday, you could kind of pick any values that you wanted. Today, it's going to be easier if you follow what I'm going to tell you. All right. So where it says number 1, you want to write down set what is inside the absolute value bars equal to 0. and solve. So I know yesterday when we did our tables, we only did 3 values. Today we're going to do 5 values. It's not really a big difference, but we're going to do 5. So what do I mean about, what do I mean? What's inside the absolute value bars? Can somebody tell me what's inside the absolute value bars in the problem that oh, actually, we're going to do one that's pretty similar, so I'll just do that. It says set what is inside the absolute value bars equal to 0. Can somebody tell me what's inside the absolute value bars there?
X minus 2.
And it says to set that equal to what?
0.
Yep, set that equal to 0. And then what does it say to do after that? Set that equal to 0
Just
and
number as the middle X.
before that though. Set that equal to 0 and solve. So now we're going to solve it. So you guys have a spot right under example 1. It says example. I think yours just says example. It doesn't say 1A. That's fine. You just put it right there. Okay, so set what's inside the bars equal to 0. Got it? And solve. Okay, how do we solve that?
Would you add 2?
Yep. Add 2 to both sides. And what does that give me?
X equals 2.
Perfect. X equals 2. That number is going to be the middle number in our table. Okay, what do I mean middle number? Well, we're going to do 5 values. It's going to be the middle one. So once we make the table, okay, you don't have to write it yet. So there's your table. 2 is going to go right there. X's and Y's. I'm going to make the table nicer in a second. But 2 is going to be the one in the middle. Now, we can't just do the graph with only one number in the X. We need 5. Okay, so how do we get the other ones? So we need additional X values. So what you're going to do is pick 2 X values that are smaller than 2. And then you're going to pick 2 X values that are bigger. And when I say bigger and smaller, we can just go by ones. So what's the next number down from 2? Yeah? 3. Down. Smaller. 1. And the next number smaller than that? 0. And then the next number bigger than 2? 3. And bigger than 3? 4. That's exactly that's how you pick your X's today. So yesterday you could kind of do anything you wanted, but that's how you do it today. And the reason I'm having you do it that way is because it's a V shape. If you don't do it this way, you won't get the V shape. That's why. So in that sense, I think it's actually a little easier because you don't have to try to figure out, okay, I need to think of a number because I'm going to have to divide it by 4. So then I'm going to pick 4, 8, and 12. You don't have to think of anything like that today. You get your middle X value, pick one smaller, another one smaller, one bigger, and another one bigger. And that's how you do step 2. All right, so I'll set it up again. Okay, what was our middle X value?
2.
2. And then we did one smaller, and another smaller, one bigger, and another bigger. Okay, you guys have a table under step 2. I know it's not a huge table, but you can fill that table in. And now, what's the other thing you need in your table? We've got all the x values, but we still need, we need the y values. Well, to get the y values, it's the same thing we did yesterday. Take each number and plug it back in. And that's how you get the y value. Okay, so step 3 is to calculate the y values using the formula that they give you. In this case, the formula is right there. That's what we're going to plug everything back into. So I'm going to copy that down so we can see it. M of x equals absolute value x minus 2. Okay, so let's start with the first number in our table. What did we say the first number we're going to fill in for x's?
0.
0. Okay, let's fill it in. What's 0 minus 2?
0. Yeah, 0. Negative 2.
Negative 2. And what's the absolute value of negative 2?
2.
Perfect. Okay. What's the next number we fill in? 1. Okay, just going from up above. What's 1 minus 2?
Negative 1.
Negative 1. And what's the absolute value of negative 1? Yeah.
1.
1. Okay, next number we're going to fill in?
2.
2. Okay. What's 2 minus 2?
0.
And what's the absolute value of 0?
0.
0. Now watch what happens here. Next we fill in 3. What's 3 minus 2?
Negative
3 minus 2 is 1. And what's the absolute value of 1?
Just 1.
Just 1. Okay. And the last number we fill in?
4.
4. Okay. What's 4 minus 2?
2.
2. And what's the absolute value of 2?
2.
2. If you notice in your table, that should always happen. The top one and the bottom one will have the same y value, and the second from the top and the second from the bottom will have the same y value. That's happening because of the way I explained how to do the problem. That's why that's happening. So that can kind of save you time. Or it can save you from getting something wrong. If you notice like the top one is a 2 and the bottom one is a 5, you did something wrong. They should be the same. All right, so now we've got our table. And what's the last thing that we have to do with those numbers in the table? Yeah. Graph. Right. Then now, sometimes they'll have us graph it. Sometimes they'll have us describe the domain and range. You'll be able to describe the domain and range once you see the picture. Okay, you just have to look at where the V shape is. But once you can see it, you'll be able to do it. Okay, so let's see if we can finish this one off. And do you guys have this graph at the bottom? Right there?
Yeah.
Okay. So now step 4 is to graph it. All right, well, let's do that first. Can somebody, I need to scroll down so I can see the graph. I need someone to read those points to me in the table. What was the first point in the table?
0 and 2.
0, 2. And the next one?
1, 1.
1, 1. Okay.
2, 0.
2, 0. Yep.
3, 1.
3, 1. And 4, 2. What shape do those points make? That's exactly what's supposed to happen. It's supposed to always make a V. So go like that. And like that. Just you can draw the arrows as long as you want. They just keep going. Okay. Let's start with the domain. What did I say the domain is for every single V shape? All numbers, never changes. You don't even have to think about it. You always put all numbers. Now, how about the range? What letter do we always use to describe the range? Yep, Y. And now, how low does the graph go?
2. Above 2.
So the graph never goes any lower than that line?
No, I'm talking about,
Zero.
I'm
Yeah.
talking about like the extreme. Then it stops at 2.
So range though, range is up and down.
Oh, sorry, 0.
Yeah, so the range is from 0 and
Above.
above.
So equal to.
So the range is every number greater than or equal to 0. Now, the last thing is to describe the graph. The V shape moved a little bit. Okay. We had a minus a number inside the bars. Does anybody remember from yesterday what minus a number inside does?
What was the question?
What does minus a number inside the bars do? That's where the absolute value normally is.
Horizontal shift, right?
Exactly. And look at where our absolute value is.
A zero.
It normally would have been at 0. It moved right 2 units. That's what minus a number inside the bars does. So how does the graph compare? All you have to do is write shift right 2. That's it. Shift right 2.
So can you go back up to number 2 real quick?
Step 2.
Yeah.
Wait, this homework tonight, 3.7.
Yeah, so the homework, let me look at the last 2 problems on here. Describe the domain and range. For the homework, I'm just going to have you do the first, actually let me look at the questions.